All right, now things change a bit. So we're going to have g of 0 plus k of 3 minus f of 1. Whoa, what? Okay, it's a lot going on, but we're going to break it up into pieces. So let's find out what g of 0 is. Let's come over here to the g graph, and we're going to plug in a 0. I'll say plug in. We're really going to go on the x-axis to 0 and find out what the corresponding y value is, which would be negative 2. Okay, that part's done. Plus, okay, now we're going to plug in a 3 into the k function. So I would say plug in, but dealing with the graph, it's not really a plug-in issue. So we're going to come over on the x-axis to 3, see, 3, and find the y value. There it is, and that y value is 1. And then we're going to subtract whatever I get when I plug in a 1 into the f function. So I plug in a 1 into the f function. There he is. And the output would be negative 1. So negative 1. Notice that I already had a subtraction from this, and then this output was a negative 1. So this is a situation where I would say, well, that's really like cha-ching, cha-ching, you know, it's that kind of situation. So I have negative 2 plus 1 plus 1. So that's 2. Negative 2 plus 2 is going to give me 0. All right, the next one, and then this one's interesting. We're going to plug in 5 into the h function. And if you're like, what about this 2? You hold your horses now. Keep all your horses, hold them. So we're going to have 1/2 times 5, and then we're going to add 3. So we plug in a 5 there. Now, this 2 in the front, that means that whatever I get from this whole situation, I'm going to double it. Okay? So this 2 is not the input. 5 is the input, but then when you're done, you're going to scale it by 2. This is a scalar. So we have 2 times. Now you might be like, oh, 2 times 1/2. I hear you. You're fine. You're not wrong. Just you could run into errors because you'd also have to do 2 times 3. That's fine. You could. I'm going to just go ahead and take care of this first. 1/2 of 5 is 2 1/2. And then plus 3 here. And so we have, maybe this is more complicated, but it's going to be 2 1/2 plus 3. I'm going to keep that 2 hanging around. If you want to go ahead and distribute, you can. But that's going to give me 5 1/2. And 2 times 5 1/2 is 11. So that final answer is 11. All right, so as we go to the next problem, I'm going to draw a little line just because I took a little too much space on that last one. As we go to the next problem, I really have 2h of x. I'm going to let x be my input. So my input is x. Well, my input is already x. So nothing really changes there. It's just 1/2 x plus 3. And we're going to double it. Okay, now there's not going to be a numerical answer. Up until this point, everything had a numerical answer. This one does not. And so this one just simply needs to be, well, simplified. My final answer is going to have an x in it. So 2 times 1/2 is 1x. 2 times 3 is 6. Done. Like, that's all I can do. And you don't have to solve anything else. You're simplifying, not solving. Okay, let's go to the next one. J of 3 minus f of 0 plus 5k of 4. Okay? So there's a lot going on here. Let's parenthesize, maybe a little too much, but there's that. We need to figure out what j of 3 is. It's going to go there. F of 0 is going to go there. K of 4 is going to go there and get multiplied by 5. Okay? J of 3, so we're going to plug a 3 right here. So we're going to have 1 minus 3 squared. We'll deal with that later. F of 0 is 3. And k of 4, say 1, 2, 3, 4, we're going to go up, find it, and it's going to be a y value of 2. Okay, we have a little bit of work to do, and it's not that bad. 3 squared is 9. 1 minus 9 is negative 8. Minus 3 plus 5 times 2, so 10, obviously. So this is going to be negative 11 plus 10. It's going to be negative 1. All right, as you look at the next one, and just because it might look cluttered if I don't, I'm going to do this again. Draw a little line here. I may want to do that on more of them. There we go. There, isn't that neat? So as we do this one, we look at it and we realize, okay, well, I'm doubling the output. Well, what is the output? Well, the output is basically whatever I get when I plug an n into the h function. So I'm going to plug an n right there. Well, it's not a number, it's a variable. It's okay, we'll deal with it. So I have 1/2 n plus 3. Oh, wait, I've got to double that. And then I'm going to add m of n. Okay, well, m of n, that means I'm dealing with the m function, and I'm going to plug an n in the place of the input, so I have negative 3n instead. Okay, and I know I have a plus and negative there. We'll deal with it. Okay, 2 times a half is 1n. 2 times 3 is 6. Notice that this is really like that. It's the same idea. Okay, and then minus 3n, there we go, plus a negative is subtraction. We have some like terms here. We have an n and a negative 3n. That's going to give me negative 2n plus 6. All right, last one on this video. We have j of x minus m of x. Well, here's j of x, 1 minus x squared. And we're going to subtract m of x, and m of x is 3x, negative 3x. And we're probably tempted to leave it like that. I want to point out that this is wrong. Okay, so here's j of x, and here's m of x, but there was a subtraction built in, so it's really like minus negative 3. I said that very sheepishly. Maybe it is, I don't know. It is. Okay, so plus positive. There we go. So let's, this is correct, but it's just super sloppy. And I don't like the order either. Let's put it in order. Negative x squared, that one's quadratic, and then we'll have our linear term, and then we'll have our constant there. You don't have to put them in the correct descending order or ascending order, because that one is not to start with, but this does look a little bit neater.